We're going to just start with each of the panelists introducing themselves. There are a couple mics with the seats. Yeah, so we can all sit for this. We don't have to stand. It can be much more conversational. Have each of you introduce yourself and a little bit about what your history is with attempting to do this. And then we will discuss, and we have the questions to start. And I'm really hoping that I have to say very little in this part. So I don't need that anymore. We can start.
Hi everyone, I'm Rezarta Islamaj. I work at the National Library of Medicine at NCBI. Where do I come in? I think I come from the perspective of the machine learner building tools, and my work at NCBI has put me in first in the research on biomedical data and biomedical literature, and now the past few years in very close contact with indexers at the National Library of Medicine, where we're trying to integrate some of our tools in the indexing system and how that actually works and all the challenges and the beautiful stuff that comes with that.
Hi, my name is Cecilia. I work at the University of Delaware. I'm part of the UniProt project. Disclaimer, I'm going to talk about UniProt. I'm not the only one working in UniProt. There's a gigantic group of people. There are some in the audience that can help out if there are issues related to machine learning that they work on. I'm more on the user side of machine learning, and I actually use some of the Rezarta's tool. And I work at, personally, my group works more at bringing literature to complement the expert curation and try not only to do triage, but extract information from that literature on specific topics. And in addition, there's some efforts at the SIB, at the Swiss Institute for Bioinformatics, who is the main place for expert curation, where there's some efforts in also applying tools, machine learning tools to help curators find information for annotation.
My name is Jennifer Smith. I am a project manager and a curator for the Rat Genome Database. RGD is a multi-species database. It's not just rat, so we do curation for mostly rat and human disease, for the most part, disease, phenotype, pathways, few other things. But we do I say that because we do cross-species curation, and we do it in a different way than most model organism databases do. Most of model organism databases go out, pull out a bunch of literature, and then try and categorize the literature and say, okay, this one has Go data, and this one has disease data, and this one, talks about some particular allele or whatever. RGD curators prioritize our curation by disease category. So we have disease portals like cardiovascular disease, cancer, a bunch of different disease categories. So we choose a disease category and then make a list of genes that are that have been predicted to be associated with that disease in some way. And so an RGD curator will start with a gene and a disease category, and then they'll go try and find literature in PubMed to actually be able to curate for that disease and that gene. And about 10 years ago, we developed a tool called Automate, which basically pulls in all of the abstracts from PubMed and tags them with all of the ontologies that we use. There's a named entity recognizer that tries to predict what genes, rat strains, that kind of stuff are in the paper, basically tags all of the abstracts with that information, and then presents it to the curator. You know, the curator can do a search to try and find their gene and their disease category, and it will present them with a list of abstracts that it thinks will match that because it's been tagged, which works better than just searching PubMed, but there could be improvements. And we're actually, I'm on the user side, so I can't talk very much about what it actually does, but we have recently started a project to collaborate with the machine learning researcher who originally developed it, who was originally at RGD and developed it. He's moved on to someplace in New England. I don't remember where he is. Anyways, we're collaborating with him to actually improve the machine learning part of this tool, because it was designed 10 years ago and hasn't been improved since then. So, so we do some, we use it, it works, it helps us, but it can be improved.
My name is Valerio Arnaboldi. I'm a software developer at Caltech, and I work for WormBase and the Alliance of Genome Resources. And at the Alliance of Genome Resources, I'm working on literature acquisition, management, triaging. We are currently developing a completely new platform for all the mods, all the members at the Alliance. And at WormBase, I work on a project called Acknowledge. Kimberly Van Auken, who is here in the audience, is gonna talk a little bit more about that tomorrow. And it's a semi-automated community curation based on machine learning. So what we do is we automatically contact the authors of new papers that we find relevant for our curation and WormBase. We extract information with machine learning, and then we present this information in, as a form to the author that can modify the results and do the curation of the paper with a pre-filled form with data types automatically recognized by our system and entities automatically extracted by machine learning. I also worked on Texpresso, which is very similar to Automate with some respect. It's based on full text, so it has a little bit more information than Automate, but it's highly focused on C. elegans, even though we have more the C. elegans there. We are currently thinking about implementing Texpresso at the Alliance for all the mod members. And that's it.
Okay, so we do actually have, I'm just gonna, so we don't have to hand it quite so far. So like I said, I'm hoping not to do too much talking here. But if we I think we sort of started on that first question, you know, sort of what are the tasks, have we tried it? I think most of us, you in your introductions, sort of touched on what have you tried to work with it on. I guess, are there any sort of tasks that we haven't yet touched on? Are there any things that you've tried that you've found it really works for, or things that you've tried where you found this is absolutely never gonna work?
We have, we build tools that are research tools from our group. Many of the audience already know this. I believe PubData we display combines all of the named entity recognition tools that we have built in our group and shows all the named entities that we recognize in the whole of PubMed and PubMed Central. Let's Suggest is another tool that is used to develop classification, literature triage of when you have a set of papers that you know these are the kind of papers that you want similar results for. I think the challenge into using machine learning for biocuration is to link the experts in the field, the curators in our case, is the indexers at the Library of Medicine, and the tasks that we are trying, the particular project that I'm working right now is to integrate our gene finding tools in the gene linking process at the National Library of Medicine. And here, there's funding issues, but there's also issues of bringing multiple experts in the field that all of them need to work together and harmonize their work. So you do need the developer, as you mentioned, of course. You need to have him on board. You need to have the experts in the field, in our case, the curators, the indexers, who know the biology, who know the chemistry, who know how all of these things link together and relate to each other. And some of them are not always acceptable of the automated tools. So there's also an education component there that you need to sort of educate, like all parties in the field need to be educated and need to understand that, yes, not everything is perfect. The automated tool are a guide or a help. I'm a strong believer of the human in the loop process, because basically language, like I have decades of experience in natural language processing, but still like language complexity is not something, even with the large language models that I hope we will get to talk a little bit later, still there's stuff there that the machines cannot master perfectly. So we do need experts in the field. We need those domain experts to be part of the process. So for me, the challenge is getting all these components together in a process that's a feedback loop that works together and gets all of that organized.
Okay, for us, we use PubData and LeadSuggest NCBI tools. Finding paper is not the main bottleneck. The bottleneck is bringing everything together and summarize and extract the information. So the focus now is more on the extraction of the data in those papers, or summarization of the information. And the thing that really work in terms of using these tools is getting close, it's the same word, collaboration, right? We have a very close interaction with NCBI group, with Rezarta's group. So we are in constant feedback on the tools. So for example, on a different project is related to UniProt, but we have a tool that extracts information of impact of variants for Alzheimer's disease. And in this tool, we use PubData. PubData can do is really well for human genes, is pretty good, but it doesn't capture, for example, certain things like proteoforms. And in a specific case for Alzheimer's disease, you will have like the amyloid beta, all these different proteoforms, and those are not captured. So we need to complement with some dictionaries in order to help there. And the same with some variants which have common names, like Icelandic variant or other types that are not. So we use a specific, we do need to do extra work, and we do communicate that. So I have meetings with John Liu explaining what things work or not work in PubData, and I know there's gonna be a new version soon. So I hope, I told him, I gave the list of all the things that are working. I hope, please check all these before you get these out. So hopefully that's gonna improve a lot. Do you wanna say?
Sorry, because Ceci mentioned it, and of course, things like this happen all the time, and maybe it's one of the questions that we're going to get to it later. When we measure the performance of tools in the research setting, we measure precision and recall, and we evaluate the accuracy. However, when we take that tool and put it in production, and you tie that tool with the intended user, with the biocurator, then you find out things that, but in your measurements, in your research measurements, you didn't think, like you're saying, oh, we are performing at 98% accuracy, that's pretty good. But there are certain things that users get a little bit more ticked off than other things. And you have to address those. You have to address those for smooth production. Like we figured out in this process that actually our users are very sensitive to false negatives. Like they do not like to see any, things that we are tagging as genes that are not genes. Like, well, don't you know that this is an abbreviation for so and so? Of course, that in another context is a very legitimate gene. But, so we had to get our tool and to get out a new version very quickly, in a very quick turnaround time, that really made sure that we are not tagging things that are not supposed to be, while also maintaining like so that we're not missing stuff. Another thing that we realized, and this is also related to a little bit what you mentioned earlier about those mouse genes that authors do not like to say in the abstract that they're mouse. We found out that our curators are a little bit more forgiving with us if we can default to human if it's a mouse organism, but they're very less forgiving if we tag as human something that is from a bacterial genome or from viral. There's a wide range, like very, very bad feelings if we are in these evolutionary distant genomes and we are tagging them as human. So that's so the new version is coming out that is more sensitive to these other organisms. So we're learning. That's why the feedback is very important, and you see what is important in the different circumstances.
Yeah, well, and I think that balance between precision and recall, where you want that balance differs very much depending on the task.
Yeah.
Like for our literature retrieval, we are going heavy on the recall, and we're living with the fact that precision is not so great. We would rather bring things in and throw them out later than not bring them in. So I guess I'll sort of move on at that, if how you think about precision recall and where the pain points are, depending on, I think, both the task and the user community. So if you guys have any more thoughts.
Okay, I'll say a couple things and I'll pass the mic, I promise. So, no,
We have it from this side.
okay, good. So I bring, part of my work is bringing literature to the computationally mapped bibliography in UniProt. So whatever I bring, I need to make sure that is correct. So I'm very mindful of precision rather than recall in that case. I know for other, like the initial triage, yes, recall, it's okay to have high recall and less precision, but in that case. And the only thing I wanted to say from before, and I'm very happy to hear you're using OnDomain. OnDomain has, the same as Spectator, has been showcased in Biocreative, which is an activity that brings together biocurators, well, users and text mining developers for applications, and I'm happy to hear that they are alive and being used.
Yes, yes, it is. It's integrated into our curation software. So, it works very nicely. Plus, we have a standalone. If you ever want to use it, we have a standalone version that you can get to from almost any RGD page. So, in terms of precision and recall, I think for the most part, we probably fall on the side of wanting the recall rather than, necessarily. We'd rather have it and realize that it's not the right thing than not be able to find it at all. But having said that, there are certain things, rat string symbols are not well matched. Let me put it kindly and say they're not well matched. And it's very difficult to figure out a way around that problem. People don't use the right nomenclature, or they only use the right nomenclature in the methods once, and then, all of the rest of the time they use whatever it was that they call it in their lab. And even if we try and have that as a synonym, it's still hard to find things. And certain of the ontologies in disease actually matches well. So our disease curation usually goes pretty well, but for some of the ontologies, Go terms, nobody uses actual Go terms in their literature. They use the language that they're used to using, which doesn't match necessarily in Go terms. So we don't always get good matches on Go terms. And the curators understand it. They know that that's going to be a problem. They know that there are going to be certain genes where they were assigned that gene, and the symbol for that gene is exactly the same, like you were talking about, as the abbreviation for a commonly used chemical, and they get 90% of the positive hits are actually negative because they're all hitting on, somebody used that chemical because it's so commonly used. So it can get very frustrating for them. They'll get, thousands of results, and 2 of them are actually for the gene that they're looking for. And we need to have a better way of being able to filter out some of that stuff. And I'm not sure that context will always help. It will help, but I don't know if it'll completely fix the problem. But maybe.
Yeah, no, I don't think we can be 100%. But we have used the context to identify, and so we have a new tool now that uses the context to identify whether, we have the article contains a gene mention, and then it further. So it works together. It's a like a feed. The model is, the 2 models work together, the triage and the gene recognition model. That's how the new tool is designed in the inside. So it's a feedback. So both, it recognizes that there is a context here that says there's a gene mention, and also tries to identify which gene or mentions are in the article. And these 2 models feedback to each other, and that's how we produce the output. That's it's better. Our curators have given us good feedback, so we're happy.
Do you want to say something?
Yeah, so I wanna go back to your initial list of tasks, and I think we pretty much covered paper identification, document level classification. I think these are all tasks that we do, even though maybe the accuracy is not too high, we can improve it, but we're all working on these kind of things. Named entity recognition, we do it, we know the challenges, but we haven't really talked about entity concept. And this is something that we're trying to explore within the Knowledge project for community curation, and it's really hard. it's the hardest challenge that we're facing right now. And we're also trying to identify sentences that are relevant for curation so that we can present those sentences to the author and say, we found this paragraph of text or this sentence that we think it's relevant for disease curation. Can you, or goal curation, can you confirm that is correct? And so another challenge that we have for community curation is that we have potentially multiple definition of what's relevant or not for the author and then for the professional biocurator. And I think this is a really important challenge to tackle because defining what's positive or negative for curation is really hard. It's really complicated also for different professional biocurators. Maybe they don't always agree on the definition of what's positive and negative. And sometimes we find very challenging to create all the classes for example, for sentence classification. What kind of sentence do we think is relevant for curation? Does it contain all the elements that we need for curation, or is it something more generic, but that can be still used for curation as context? So I think we need to really think hard on when we create these training sets on how we're creating them. Not only that we're leaving out we're creating some bias by selecting more positive than negatives, but also on the classes on the labels that we assign to the observation. I think we have a lot of work to do there as well. And I think accuracy recall, it's always challenging because professional biocurators and the community, they're used to high quality data. So if we provide something that is quite good from machine learning point of view, like 90% accuracy, sometimes it's not enough for curators and for the authors and for the community as well. So it needs to be defined on the context, on the specific task, but the fact that curated data is really high quality makes it much more complicated to apply machine learning. What we do at WormBase and for the Knowledge project is to try to use simple methods or maybe hybrid methods where we apply machine learning, we apply regular expression or string matching all together to really make sure that we're extracting the right thing. Another challenge that we have is we identify gene names, let's say gene names in a paper, but we are not really sure if all those gene names have been used as the main subject of the study or not. So what we do at WormBase is to use like thresholds and say, this is the TF-IDF threshold for this gene. It's mentioned so many times in the paper that it must be important. And so we present it to the author. Otherwise, we will present a long list of genes, maybe extracted from the supplement, but those are not really relevant. It would be frustrating for the author to go through a really long list and validate all of them. But sometimes it's also confusing to communicate to the author what kind of information we want from them, because the definition of the information, again, of those classes or labels, it's very challenging, and it's hard to say what is how can we define if a paper contains disease information? Is it a disease model you're looking for in the paper, or is it generically related to disease? So those are, I think, in my opinion, the main challenges that we have.
Yeah, we're at UniProt, we are trying also some community curation approach, especially to complement for those species that are not actively curated, to bring more literature and some annotations. Currently, we're asking users to just add free text for specific fields, so like function or disease or subcellular location. And the idea was, we have a similar plan that you already implemented in terms of contacting authors. We already have tools that extract some kind of specific relations from the text, and we were planning to send that to the authors for validation. But other plan that I have for the existing annotation is, since the author already added like the sentence with a function, trying to match that to a Go term or to a structure vocabulary, subcellular location, which is I think it's easier than asking the user to add a Go term. So I don't know, we'll try and see. But in terms of one of the aspects that I think we'll touch upon later, but I don't want it to miss, is that a lot of our curation effort in UniProt is going to creating corpus, helping to create corpus, because all these machine learning things need some, can be used pre-trained models or fine-tuning on some existing data, but whenever you have to apply it for your task, you do need to create a corpora, right, like annotation. So that's an important effort that deviates from, which is very different from your regular annotation.
When you were talking about the number of times something is mentioned in a paper, it reminded me that one of the challenges, particularly with disease curation, is that very often authors will do whatever they can to say that what they're doing has to do with whatever the most popular disease that's getting funded now is, whichever one that is, it's Alzheimer's. Everybody's funding Alzheimer's. So we're going to figure out how to say our research actually has something to do with Alzheimer's. And so what an author thinks actually makes it related to Alzheimer's, and what a curator is willing to agree it actually has something to do with Alzheimer's can be very different. And they'll mention Alzheimer's multiple times in the paper, but it actually doesn't meet the criteria that we use for being able to say this gene actually has anything to do with Alzheimer's.
Yeah, I was just gonna say, yeah, in relation to that, one of the things that I know, like our expression group has found, is they really want to target specific sections of the paper. So they have changed the way their sort of searches work to really look at like the figure legends and sort of ignore. And I know for like disease, you kind of want to ignore the introduction and the discussion. And if they really mention it somewhere, at least personally, we look for like something that clearly says that it's a model. But it's, yeah, it can be very touchy, and it's sort of getting to one of the later questions. It's really hard to go between various journals and figure out what the sections are because they all do them differently. And the one thing I did want to say at this point is if there are any questions or comments or anything from the audience, please feel free to just put your hand up and get a mic. We're at 40 minutes? Okay, so there is a clock up here that says 29, so I'm gonna hope that that's, when it hits 39, we'll see if that's right. Okay, thank you, Len, I was thinking the same thing. Any questions to do time to ask?
So you've been talking about the body of papers and then abstracts, but it seems that like supplemental material is a much more difficult problem, both because it's less structured, but also you may have tabular data that has a lot of false positives, I guess, from the perspective of this RNA-seq tables or whatever that may have genes that don't change. It's difficult to pull that out just by context. So have any of you tried to make attempts at really digging into the supplemental data?
I would say all we really have done is manage to identify when the paper does have supplemental data, so we know we need to go get it. I think in general, we've sort of taken the opinion that if they don't mention it somewhere in the main paper, that it's probably not enough of a focus to have us really worry about. But I do know we've run into that, especially with expression, where they don't start to tell you about the developmental stage until the supplement. And so that's sort of part of our secondary screening is once we get the supplement, we'll actually run the same sort of classifier over it. But we don't necessarily get into like the Excel spreadsheets. It's sort of more the text.
We haven't done it yet, but we've just started a project, trying to improve Ontomate. But one of the kinds of curation that we do is quantitative phenotypes, where we actually need numbers. It's not enough for the author to say, you know, the blood pressure increases and they show a graph and everybody goes, oh yeah, the blood pressure increases. We need the numbers. We actually need to know that this one is 120 and that one's 170. So we particularly want to be able to use the supplemental materials because most of those, like you say, the spreadsheets and those kinds of things are in the supplemental materials. So we haven't done it yet, but we're working on it.
Yes, unrelated question, but yeah. Hi, Chris Mungle here. I was struck by what you were saying, Jennifer and Cecilia, about the difficulty of recognizing things like Go terms in papers because authors don't often use the same language that ontologists do. And I work on a number of different ontologies, and I'm kind of struck by the fact I very rarely hear feedback from NLP people about what we could do to make the ontologies better for NLP. And I'm not quite sure why that is. And also I hear sometimes people do things like, oh, we just throw out any synonyms that are not exact synonyms, which will drastically reduce the recall of your methods. And I'm wondering, should there not be more interface between the ontology community and the NLP community? How can we do that?
Thank you, Chris, for that comment. We did have some interaction with, and actually with WormBase, some Go task in Biocreative to bring NLP, and we have curation with Go, full text paper curation with Go curators, but I guess we can extend the results are never very good with the code terms. We tried 3 times already in Biocreative to get systems to recognize gene ontology terms, and it only works well with cellular component, but the rest is very hard. And I mean, we try, but we can continue to talk, and yes, maybe there are possibilities. I agree, we can improve that. But when I was saying that I usually have I have students which I teach ontologies and how to apply Go terms and annotation and so on, and it's very hard for them to do that. Even if they receive the full explanation from scratch what an ontology is and how you use them, and I find that if they find it hard having the training. The authors of a paper trying to identify the right Go term for their statement is more.
Yes, my name is Colby Reed, and I, as somebody who deals with a lot of homolog aliases and things like that. So you guys mentioned the problem with chemicals coming up and a lot of false positives. I deal with that quite a lot. But the thing that I noticed that could be particularly useful, and I don't know if it's been something that's been tried or addressed, I haven't seen anything, I have searched, believe me, is case sensitivity, because a lot of those particular formats that I keep getting picked up are like, for example, elemental compounds. So in particular, for one example, nickel fluoride. So big N, little I, like that could potentially throw out a ton of false positives, but also consider the capitalization differences in a lot of schemes for gene naming and symbols. That could potentially be pretty useful. And I would like to hear your thoughts on that.
We already incorporate that a lot because capitalization and other clues are very, they have semantic meaning, and it could be different in chemicals or in genes. Like for genes, capitalization may mean that we're dealing with a human gene, while lowercase may mean that we're dealing with a mouse gene, and stuff like that. So yes, those are included in our tools, at least. I wanted to make 2 comments. One, is 2 sub-comments about the concept name recognition that you mentioned earlier. There's two challenges there. One is that the ontologies are not good enough and we are facing new terms. Especially we have new strains for new organisms that we are identifying, and those have not been cataloged yet. And this is a challenge for natural language processing tools. The other one is when, and also for new chemicals, so that they are not recognized yet. I actually have a talk on how we address the development and developing new vocabulary terms and identifying them, helping the curators to identify new vocabulary terms. The other one is when authors use a common name to refer to, like for a gene, for example, to refer to a group of organisms, or for a disease to refer to a family of diseases or a family of proteins. And again, the ontology is not always categorized, and it is difficult to come up with the right concept identifier when we have, so both very specific that we don't have, or very general, but not, I mean, there's a sort of generality that again is not captured in the vocabulary or ontology that we have. We have previously in the past, we have experimented with picking up and combining two different ontology terms. For example, when explaining something that has to do with two diseases or with two chemicals or something in combination, we found out with the curators that they don't really kind of prefer that. So it's a work in progress. The other comment I had with what you mentioned earlier, that in the papers is different because journals have different format, like which is the results section, or which one is the discussion session. This is something that we try to address with our BioC format. And every paper in PubMed or PubMed Central, we have the BioC formatted version that is available for free for download. And in there, we try to do an educated guess, and there is a tag saying that, well, this is most likely results, this is most likely discussion to the common things. But that's another challenge that we have found. And that's also related because for biocurators, they try to find the evidence sentences for indexing or for curating, which is different from what the authors would like to build up the importance of their paper. So it's kind of a trade-off.
Yeah, so I think we are just about out of time. I know they're going to talk more about large language models in the next panel, but I know you brought that up at the beginning, so I just wanted to give you an opportunity. If you had any specific questions, we can seed that conversation a little bit.
Since it came out a few months ago, it's been like I've become really curious, and I've tried to do my own experimenting, trying to figure out how well these models can be used for biocuration. My personal conclusion is not yet. I do believe there is a lot of potential in there, but not at the moment, I think. Some of my personal experimentation has shown that the model can give you concept identifiers that are not real concept identifiers. But if you give the model the text and the concept identifiers, sometimes it's very adept at giving you the right relationships between those concept identifiers. So I think there is a little bit more work to do there, but I think that, yeah, I'm very curious. I will follow the next discussion with a lot of interest.
Yeah, so I've got a more procedural question. So being a NCBI now Eagle Genomics curation lead, we work outside the biomedical and model organism area. So how long does it on average take you to build a new dictionary to then put into your tool and go through the whole process of assessing your recall and precision for a completely different field?
I'll just say, I think that's an interesting question. I don't know if we have.
I can say it's a long time.
Yeah.
Thank you.
That would be my guess.
That's all I need to tell my boss, because they always think it's so easy.
Well, and just for some of the tools that work really well for one group fail entirely for another group. Like a lot of the tools that work for the rat genome database, we've tried them at MGI and have never been able to get them to work, just because the way the literature is written is a little different. When we're talking about the using capitalization, that requires that the authors actually follow the standards, and it is all over the place out there. Sometimes some authors are very good, and I have often want to give them gold stars. But there can be a lot of variability in how things are written. All right, and we seem to have another question. Wait. Oh, sorry.
Yeah. Okay, no, I just wanted to follow up a bit with what Chris said and some of the other things that people have mentioned that I think, and maybe this would be a good thing for the future workshop, is to talk a lot more specifically of how we can help curators, help machine learning developers, help ontologists by making it as seamless as possible in the existing workflows that they have to feed back to these people. So for when you're curating a paper and you find conceptually, a synonym, how easily can you get it back to Go or one of the other ontologies? I think that's really, really important. We've talked about how critical it is to get very good training data, but that's not easy, right? That's very time consuming. So anything that we can do to help this happen, facilitate this with the workflows that curators currently use, is something that I think we really should focus on.
And we should also include authors in the loop, because it's very important to make them understand that it's hard for us, because sometimes they're not using standard nomenclature. So letting them know that the results are not great because of that makes them aware of the issues that we're having. And I think it's really important. For community curation, we see that we don't get a lot of feedback, though. I think it's very important to reach out to the authors and make sure that they use standard nomenclature. And the journals. So we have some small projects like micropublication, for example, that is experimenting on while you're writing the paper, we identify the entities right there, and we make sure that they're using standard nomenclature. I think that's a very important step that we should think of. Yes. So including journals and authors in the loop, I think it's very important for this reason.
I think we need to
Yeah, the nomenclature is very important, especially for chemicals. Authors are terrible. We have had cases, because chemical writing is so sensitive, you change something and it's the opposite chemical. And our curators have captured something that was completely opposite because the meaning was. So I am a big proponent of the loop, of having the author, the curator, and the machine learner developer to talk together, because that's the only way that we can get the right information out of curation.
Okay, and I think that's a lovely way to close this first half of the workshop. We're going to take like a 5-minute, 10-minute bio break, 5-minute bio break, and then we will come back and we'll have the second panel, and then hopefully some time for discussion at the end.